And this stage, this pizza slice called the answer stage, is now ready to welcome another remarkable speaker. He's a great team member and excellent, I might add, as his colleagues say, and he likes to talk in public. We all who listen to him talking in public enjoy it, especially having in mind that he's a front-end nerd who works on the Vue.js core team with a particular focus and interest on its official router. He started, of course, as a user, so he knows all the pains of it, but now, surely, he excels in the most difficult tasks. You can see how special style he has, and he moves really quickly. So if you would like to catch him today during the day or during the after party, you also need to move very quickly. Also, one thing I need to emphasize is that if you like to talk about the future, if you like to imagine how things will look like in the future, how things will function in the future, you have to be really concentrated in the next half an hour because, ladies and gentlemen, himself is going to speak about all the non-existent things in the front end. Are you ready?
Almost.
Almost. Ladies and gentlemen, let's give it up for Eduardo San Martin Morote. The floor is yours. Enjoy it.
Just want to make sure I'm late. Perfect. Where is it? Okay. Hi, everyone. Thanks for having me. So yeah, my name is Eduardo. I'm a member of the Vue.js core team. So I'm the author of the router. And I'm also a freelance in front-end development because, you know, GitHub's open source is really cool, but it doesn't really pay off the bills yet. And you can find me around as Posva on Twitter and GitHub, where you can find my not so organized code. But in real life, I think I'm more or less a well-organized person. So this is my desktop. As you can see, I have a few files around, a few folders, I think like pretty much everybody. But I do try to remove them from time to time. And among those files, I have a screenshot that I take a look at quite often. And some of you might think, oh, it has to be a picture of someone he loves, a cute picture, a dog, something like that. But no, it's just a screenshot of Stack Overflow. I took this like 2 years ago. And it doesn't bring me joy, but it brings me hope. It says, HTML5 specifies a hash change event, and this event is now supported by all modern browsers. And when you look at the list, you have Internet Explorer 8, and then you have one-digit versions for Chrome and Firefox. So you can imagine how old this is. This is from 2009. Internet Explorer 8 actually came out in March. It didn't come out. It took over Internet Explorer 7 in March 2009. And I find this reply funny because today nobody uses hash change. But back then, in 2008, 1 year before that, that was the only way you could do hash-based routing or just client-side routing at all with single-page applications. You could use something like Mootools to do this. And today, 2021, you not only have hash-based routing, but you also have history-based routing, and you can use any framework you want, any router you want, right? So I was wondering, was on-hash change event really possible to use back then? So we couldn't use regular URL at all if we wanted to have single-page application navigation, but was really on-hash change usable? So if we take a look at browser market share, and I'm not even including anything beyond Internet Explorer here. But you can see that the only one that supports that is IE8. Now, imagine for a second, try to guess the browser market of IE8 1 year before it superseded IE7. Just for a second, try to guess it. And the answer is 0.37%. But that's not the shocking part, I would say. The shocking part is that IE makes up for 70% of the browser market share, and they don't support on-hash change. And we all know how long it takes for IE to die, right? It's still dying today. So we know that in 2009, it wasn't possible to use on-hash change. Now the question is, how do we even do that without on-hash change? How do we detect that the URL has changed? And the answer is polling. Now, I'm sure that nobody here will actually include this piece of code in their actual production. So polling is basically running a function every X time to check that something changed. To be fair, if you do AngularJS, you may have included something like this in production. Guilty myself. But this is not how we'll do things today, right? So that's why I want to talk to you about the future of modern routing, of routing clients and routing, sorry, and explain a bit more of the concepts behind the scenes. What do we use today? What we can expect from the future? All of that. Now, before going into what do we use today, let's talk about what is a router. A router is the piece of code that is between you and the URL. And sometimes you also have other things in between. You may have a history module that handles the connection with the URL bar. You may have what I call a matcher, which is basically what extracts the useful information from the URL. And you may also have components. So if you're building a React application, you're going to have a view component or a link component. View is router view, etc. And nowadays, all modern routers use the history API. We don't even use the hash change anymore because we don't need it. The pop state event that we have works for the hash change. So we have these few APIs. It's really, really simple. We have two functions, push state, replace state. Now, the first argument is useful. It's called data. It's like a state that you can pass to your history. The second argument title, it's like main nipples. All this time, and we still don't know what it's about. Safari is the only browser that actually does something with it. And URL is pretty self-explanatory. You change the URL in the bar, that's it. Then you have this pop state listener that allows you to know when the user goes back and forward in the history. And you can check the state, which is the data that you passed before, and the length of the history, which is not really useful. But whatever. The way it works is we go to a place, the state is null, the length is 1. We can push state. That's going to change the URL, change the state, and increment the length of the history. Then we do it again. It's going to happen the same thing is going to happen. And then what we can do is go back. So that's going to change the URL, the state, but the length of the history stays the same. Not that it matters much because you cannot do much with it, but still. And then you can go forward to go back to the final state or final entry in the history stack. But when you think about it, how do you interact with the URL? The way we interact with the URL is different depending on the section you want to read. Now, I'm going to leave aside the domain because you cannot really change that. That would be the dream for any hacker because you will be phishing everybody. But we have the path, the query, and the hash. And sometimes they are known as the path name, the search, and the fragment, which doesn't help to make things easier, by the way. And so all of them are accessible through this global object called location. You can read the path and change it through path name, the query through search, and the hash through hash. And you can change the whole thing by changing href as well, changing the whole URL in one go. Now, we don't do this anymore, but we can actually change the URL by changing these properties. We can change and do a full reload, a full navigation. The only one that is not going to trigger a full navigation is the hash. But today, we don't use this anymore. Why? Because it's going to trigger a full navigation, which is exactly what we want to do. So we have to do a push state instead. But this is not the only place where we had to change something. We also had to change how we handle links. Now, if we have a link like this, it's going to trigger a full reload, which is not what we always want. So instead, we use our favorite framework to specify the link component that we want. Now, this makes the API quite inconsistent. And it's not the only problem the history API has. But basically, we can no longer interact with the applications the same way we were doing before. So all these things that we're doing with the history API are no longer possible. And it means also that since the user can navigate through the application in different ways, we have to constrain how the developer uses the native APIs in order to maintain a single page application navigation flow, which means we just stay in the same page. We do not reload the page, basically. So what do? We have a new proposal API for another API. And so the API as we know it today becomes something like this. And it's called the App History API. It lives alongside the History API. It doesn't replace it. And so instead of having two functions, push state and replace state, we now have one single function, and that function is going to have that replace argument later on. We have the state, which is the same as the data from before, URL, which now can be also a full URL, and info, which is what we call a transient state from the history, which means a state that only exists during the navigation, but is not persisted anywhere, like the state is. And then we have these event, navigate, which is no longer on the window, which didn't make any sense either. It's now on the app history. And we get access to the history stack in a different way. We have the current history entry, and then we can access every single entry on the history, which finally makes it useful. Now, let's take an example. When we navigate, we can pass pretty much any URL. So this means that navigate is closer to changing the href than doing a push state. And why? Because it's going to trigger a full navigation by default, which means that it's going to reload the page by default, which means that we now have scroll through fragments working out of the box, which is not the case for routers. They have to handle that themselves. It can be cross-document, so it means that you can also push a full URL, which you cannot do with push state. It returns a promise. Now, this is a big surprise, because history push state doesn't return anything. You cannot really know if it's finished, if it's not finished. And on top of that, depending on the browser you're using, it behaves differently. So it's really a mess. It synchronously updates the URL, which is not the case for push state, depending on the browser, so it's even worse. And it can also be rolled back very, very easily, which is, it's so great, honestly, as a router library author, rolling back URLs is a pain. You have to test in every single browser, and most of the time, you have to keep trace of where you were with deltas and stuff. It doesn't work all the time. You have to handle fragment navigations. It's a mess. Let's look at a more realistic example. So let's turn all these arguments into real ones. Let's say we go to Slack projects. We can save the list of the projects we want to display, and maybe we are leaving a new project page. So we want to prompt the user, do you really want to leave this page or not? Now, this is not enough. You still have to add this add event listener navigate. Otherwise, we're going to trigger a full navigation. And this is going to give us access to what we call a history, app history navigate event that has a whole lot of things. Now, this is not the whole list, by the way. But we can know if it's cancelable depending on how this was initiated. We have this new transition while, which is very interesting. The type of navigation, a push, replace, reload, so many things. If it was initiated by the user clicking on a link, or if it was through code calling JavaScript API. And then we have the destination, more about that in the future. Has change, was it just a fragment change, or was it a full navigation with the path name, the query is changing? Was it a form submission, the transient state we talked about before, and signal, which is an abort signal that you can pass to a fetch to abort any ongoing fetch requests. I will talk about more about that in a moment as well. So I'm going to focus on these ones that I want to explain. Let's take a look at this example. We can take a look into destination, see if we are staying on the same page, so to say, the same domain. And if we are, we can call prevent default. What this is going to do is it's going to prevent completely the navigation from happening, okay? So it means that the navigate function is going to return a rejected promise. Or more like the promise is going to be rejected. And the URL is going to stay the same. It's not going to change. So that's pretty cool as well. And as you can see, we have the catch for the promise instead. Now, if we use a transition while, this is where things get interesting, okay? The transition while receives a promise. And this promise can reject or resolve. If we just give it a promise that resolves, we can then use a then, and we're going to get a promise that resolves to nothing at all, but we know that the navigation finished. And what's interesting as well is that no matter what we pass to transition while, after we call the navigate function, we know that the URL is updated. The location.pathname is going to reflect the actual value we want to go. This also means that if we pass a promise that rejects, it's up to us to revert that URL back to what it was. But with the rollback function we have, it's going to be very, very easy. So even though we have a catch, it doesn't change the fact that the location path name is the same. Now, let's take a look at a more realistic example here. where we pass a promise and we do multiple things. In this case, I'm calling a fetch data that is supposed to put it somewhere that we can use. We have a transition out of the components that we have in our page. So they go outside, and then we put inside of the page the new ones. And then we just call resolve and reject. And if you want, you can also change this piece of code into something that is called an asynchronous, immediately invoked function expression. So a long name for just something that uses async await, basically. I think this is more readable than the other one, but you have to get your head around it the first time. Now here, we can now use the event signal to fetch data. And if the navigation gets canceled anywhere else, so imagine the user clicks on the same link twice or something like that, the fetch request is going to get aborted naturally. You don't have to do anything at all. So this is pretty neat as well. And navigate is not the only event that you have. We also have navigate success and navigate error. Now, if you have used Vue Router or Angular Router, you probably have used navigation guards. So this is similar. The difference is that you cannot really control the outcome of the navigation, right? That's at the router level. But you can still know if the navigation failed or succeeded. And you can send analytics or anything you want. You can even send performance metrics out of this with a performance observer. So that's pretty cool as well. And on top of that, this is just an event. So you can just attach that event as many times as you want. And all these event listeners can receive a different promise. Each of them can receive different promise coming from different places. Now, I'm not a big fan of micro frontends, to be honest, but this is so much better than having multiple routers for micro frontends, because you can have, not only you can use transient state to know what part of the application is triggering the navigation, but you can also combine all of them in one single transition that is coherent. And all of these things that combine into one single transition object that expose multiple things. One of them is this finished property, which lets you know if the navigation is finished by pretty much calling promise all on all the promise. But that's not it. We have more things that we can do. The transition contains the type of the navigation, but also the app history entry we are going from, and a rollback function. Now, the rollback function is very cool because you can just call it that way, and it's going to roll back the URL, the state, and everything to the previous location we were at. So that's pretty convenient. But more interestingly, the app history class that we have here. Now, this is just a sub part of the class. The real one is a way longer. But as you can see, it extends event target, which means that we can attach event listeners to any of the entries on the history. And you can see that we have two properties here, key and ID, which are a bit special. You can read them on any history entry, and they are both browser-generated UUID identifiers, basically. This is something that I've seen at least asked for in all mainstream routers, okay? A way to identify a single entry on the history. The problem is that the history API is not consistent. So we cannot really provide this kind of solution for 100% of the cases. We can for like 95% of the cases, but there are cases like with fragment navigation that are not consistent, especially depending on the browser, and we cannot get around those. So the interesting thing about these two IDs is that they do very different things, as you can imagine. The ID is specific to the entry information, which means that if you replace the state, or if the URL changes, the ID is going to change every time, kind of like a checksum. While the key is specific to the entry itself, which means that no matter what you do to the entry, change the state or whatever, it's always going to point to the same position on the history stack. And this is very useful because it means that we can just go back or forward to any entry without having to rely on deltas of numbers, like minutes. Was I in that page 2 times before, 3 times before? Did I have an iframe that did a navigation and messed up my history length? None of that matter anymore. So I don't know about you, but nowadays, when I use any application where I have long form or I'm searching for something, I'm so afraid of messing up the application by hitting the back or forward button that I don't use them at all anymore. unless the application shows me a back button, I don't use them because I'm afraid I'm going to lose the search I was doing, or if I'm in the middle of purchasing something, it's going to disappear. Now, with this thing, imagine the situation you want to go nomad. So, of course, it's not the best year to do, but let's look back a few years or maybe in the future, who knows? You might want to look into different cities, the prices, the different places you want to go, and maybe you decide, oh, this travel path I'm taking doesn't really fit what I want, so let's go back and try again. Because now you have this function, history go to, you can just display a link or a button somewhere in the interface so the user can just go back or go forward, and you make sure that nothing is going to break unless you break it yourself as a developer. But no matter the interaction the user does in the web application, the URL and the state associated with it is going to stay stable. So about that target, you can actually retrieve absolutely any entry in the history. Now, there is one thing about it, is that you only have access to the entries that are specific to your web application, which means that same document, so no iframes, that would be weird. Also, it will be a security concern, and no cross-domain, of course. But you can attach even listeners to them. So for example, you can attach and navigate from listener to any history entry that you have, which means that before leaving the entry, you could call a date current, which, by the way, only works if target is the current entry, as you can imagine, but I wanted to simplify the example a little bit more. But you can do that, and you just have to call a date current, and it's going to add any state you want, which is very useful. For example, cache purposes is one of the cases that is nice. And this is not the only event that you get access to. You also have things like navigate to, finish, dispose. I will not get into details on this. All of the information I'm sharing is open on GitHub anyway, but the navigate from is definitely the most useful among them. Now, to summarize the whole thing, the App History API brings different things if you are a library author or a developer. As a library author, this gives you a consistent, predictable, and extensible API, which was definitely not the case at all for push state, and definitely less workarounds around specific browser versions like Internet Explorer not firing pub state for hash changes, stuff like that. As a developer, you're going to have lighter router libs because they can use the same API. You have less bugs because you don't have to care about all the non-defined behaviors of this API. It's way easier to integrate with micro frontends architectures. And you have routers that can be extended the same way, no matter what front-end framework you're using, which is really great. Now, that's pretty cool, but when can I use it? No idea. Honestly, the feedback so far is only Chromium. So what can we say? Is this going to be 2024, 2022? No idea. I just think that it's going to be faster than API changes in the past, because with automatic updates, things are a bit different. But it doesn't bring that much hope to see that nobody else is participating in the API. So I want to talk about other APIs that exist that you can actually use nowadays. Now, these are maybe APIs that you have used now because they have been there for a long time, URL search params and URL. They do have a little problem, is that our friends Safari and Internet Explorer are not very friendly with these APIs. So Safari has minor bugs. It's fine. It has encoding bugs on some functions. It has been fixed. It was like version 10 or something like that. It's fine. The problem is AI. AI doesn't even implement these APIs. It just throw them away since the beginning. And at least it's dying, so we can now use these APIs comfortably, unless you have to support Internet Explorer 11, which I'm sorry for you if you have. But they do offer a lot of things like URL normalization and handling encoding values. And I don't really want to go into the details of encoding. It looks like it's simple, but it's not that simple. You have different values to encode depending on the section of the URL. Is it the hash, the search, or the path name? Well, that's all different. And then you have to encode pretty much any character that is not ASCII on top of all the symbols. And we only have two functions in JavaScript, but we actually need to patch a few of the changes to not over-encode things, which is not a big deal unless you want a pretty URL. And about pretty URLs, well, that's another topic, because browsers just don't display and don't handle unencoded values the same way at all. So the example on the right, you pass an encoded value, it's just going to work the same in all browsers, at least when it comes to reading the value, which is the most important. But if you pass an unencoded value to the browser, good luck with that, because not only is it going to give you different results and invalid results per spec, but some of the browsers, I mean, it's not a browser anymore, but Internet Explorer didn't even do anything with whatever you passed to it. Safari did some crazy stuff there. It doesn't make any sense. And Firefox and Chrome are fine. The best one is there. The best one there is definitely Firefox, because you have a version that is readable for the users, and you have the actual encoded version as a developer, which is exactly what you want. But anyway, and so all these APIs, you can already use them, okay? They have been there for a long time. They are great. But what about something new? Now, this is a snippet of code of an Express application. What I want to focus on is the actual string that we pass to that get function, the user/name. This is a special syntax that allows you to extract a section of the URL and to match dynamic URLs, so parts that change. Behind the scenes, pretty much any library is going to create what we call a path matcher, a pattern, whatever you want to call it, that allows you to match against a string and extract and say, yes, this string matches with this pattern, and this is the param that we had inside. This is what I call a matcher, and the way they work behind the scenes usually is by transforming these string representations into regular expressions that can extract a part of the URL. You also have radix trees, but I mean, they do offer some advantages and disadvantages compared to regular base expressions. But I'm not going to dive into them. There is one problem with this approach, though, is that you depend on the order these routes are added. Now, in server side, this is not an issue, because you add all the routes one after the other. On client side, though, you don't always control how the routes are added into the router. So if we want to go to user search, then it's going to try one per one, and it's going to stop as soon as you find a URL that matches. So user/name, sure, that works. The name is search, let's go ahead. But what we wanted to match was actually the last one with the static section of search. And the way we solve this, some routers do, is by specifying a score to every single path that decides which one is more specific, which one is more, it's supposed to match less things. Then we order them correctly, and we match them in the right order. So we stop in the first one we want. I won't go into the details of how this works, but because we have different algorithms to handle, but basically it's heuristics that sort them differently. And the API that exists to solve this partially is URL pattern. Now this one does have a polyfill that you can use, so that's great. It's quite heavy, if you want me to be honest with you, but whatever. And you can have patterns in any section of the URL, the path name, the query, the hash, anything. What it doesn't solve, though, is the ordering. That's something that is not solved at all. There is a proposal for URL pattern list, but like it's supposed to work like in service workers or web workers, but it's not really, there is not really a conversation yet about it. So this is why I was showing you at the beginning this screenshot. It's because even though these APIs are just at the proposal stage and we're still waiting for a lot of feedback from the vendors, the browsers, the hash event is no longer used anymore. We have another API that superseded. So I feel confident about this API taking over in the following years and enabling a much better experience when it comes to routing, which is nowadays quite difficult as a user and as a developer. I mean, as a developer of the library and as a developer that uses the library, who uses the library. So hopefully this will bring a more stable API, something that we can use, and we can rely on the same kind of API for different frameworks. So something that is much better. And I hope that it also makes you more confident about the future of routing and not making the experience a pain, which I think sometimes it is. Thank you.
Thank you very much, Eduardo. I hope you enjoyed being on stage as much as we enjoyed listening to you.
Thank you.
But we know that you like to talk in public, so I presume you enjoyed it.
I like it, yeah.
Yeah, okay, so enjoy Zadar now. Guys, ladies and gentlemen, I have some good news and bad news. Which one do you want to hear first? Bad one, it's coffee and cocktail break. And the good one is also it's coffee and cocktail break. So yeah, got you there. Anyways, because you enjoyed all the lectures and everything. So enjoy it. Don't overdo it with alcohol because there are some great speakers who are going to be on the answer stage once we get back. It's still hot, it's sunny, it's beautiful weather, so have fun during the break. But please be here on time because at 4 p.m. sharp, we would like to start. Plus the thingy in academia and all that. But don't count on that. We're just being good people here in Croatia. So thank you once again. Have fun. See you at 4.